Hello again, fam. Hope everyone is doing well. Today's lesson, we are going to verify these trigonometric identities that we've been talking about. Now, go ahead and warn you, sometimes these take a little time. So they are a little difficult, a lot of times only because they are long, and they require a lot of basic math that sometimes we forget about how to do basic math when we have sine and cosine and tangent and squares and everything. So there are some suggestions to help us verify the identities and understand what verify really means is we're proving the identity is true. All of these equations, they are true. We just have to prove that they're true. Now, in order to do that, we can't assume they are true. For example, here's the difference. You can only work one side at a time. Like you can't move anything from the left side. Say if I wanted to move that secant squared x over to this side, I can't do that because then I'm assuming that they are true. And you can't assume they're true. You're trying to prove that it's true. So you can't make any assumptions like that. Okay, all you can do is work with each side individually. And basically all you're trying to do is get the left side equal to the right side. And once you've done that, you've proven the identity. There are a few suggestions right here. Okay, I'll leave these up just for a second so we can read them. The first suggestion is to transform the more complicated side of the equation to the simpler side. You have substitute one or more basic trig identities to simplify expressions. We'll do that almost every time. Factor or multiply to simplify expressions. Multiply expressions by an expression equal to 1. And then finally, express all trigonometric functions in terms of sine and cosine. So it's very, very similar to simplifying trigonometric expressions. The only difference is you're doing it on both sides or one side. You're trying to get one side to look like the other. Okay, so we're going to use these trig functions, okay, or trig identities, I should say. Again, we're going to concentrate on the reciprocal identities, the quotient identities, and the Pythagorean identities. All these other identities, they are identities, but the video would be an hour long if we went over all of them. So we're just going to concentrate on those three. So for our first example here, we have secant squared x minus tangent x times cotangent x equals tangent squared. So again, the more familiar you are with your identities, the easier these will be. And I wish there was a better way of learning it, but doing them is the only way to learn. This is kind of teaching you how to think mathematically. How can I replace and move and just maneuver my information around to where it equals, okay? And so here is a pretty simple one, believe it or not. I'm going to leave secant squared just like it is for now because what I see is I see a tangent x times a cotangent x. And hopefully you remember that tangent and cotangent are reciprocals. And anytime you multiply reciprocals, you always get 1. Again, I'm going to use just regular numbers to prove this. 2/3 times its reciprocal is 3/2. Well, that's equal to 6/6, which is 1. That always happens. 1/5 times 5/1 is 5/5, which is 1. So when you have tangent and cotangent, which are reciprocals of each other, multiplying, they will equal just 1. So we end up with secant squared x minus 1 equals tangent squared x. Okay? Notice I worked the left side because it was more complicated than the right side. That's one of the suggestions, is to work the more complicated side. So I'm trying to work with the left side here. All right, moving on. now I have this secant squared x minus 1. Well, I have right here, under the Pythagorean identities, I do not have secant squared x minus 1 equals tangent squared x, but I do have tangent squared x plus 1 equals secant squared x. So all I really have to do is move that 1 over, and now I can use that trig identity. It's a Pythagorean identity, and obviously if I move that 1 over, I'm left with tangent squared x, which is what I'm trying to get. And as soon as you get the same on both sides, you are done. We just proved this identity. We proved that secant squared x minus tangent x times cotangent x equals tangent squared x, okay? Next example, again, cosine x equals cotangent x divided by cosecant x. I will do the right side. It's a little more complicated than the left. And the suggestion I'm going to use on this one is to change everything to sine and cosine, okay? The left's already sine or cosine, so I'm going to change the right to sine or cosine. Cotangent of x is the same as cosine of x divided by the sine of x. Divide, okay? Now, cosecant x, it's the same as 1 over sine of x. And from there, it really is basically just doing math. We're going to multiply by the reciprocal because we're dividing two fractions. So sine of x over 1 up here, sine of x over 1. And what do we get? Well, these bottoms cancel, obviously. And then up on the top, sine of x and sine of x cancel, and we're left with cosine x divided by 1, which is cosine x. And as you can tell, we have cosine x on both sides. So we're done. That one's not too bad. All right. Example 3. We have 1 over tangent x plus secant x equals cosine x divided by sine x plus 1. So this looks like a good one. I am going to start on the left side because, again, if we follow our directions or suggestions to make everything sine or cosine, the right side is already sine or cosine. So what I'm going to do is I'm going to change these tangent x and secant x. Tangent x is the same as sine of x divided by cosine x, plus secant x is 1 over cosine x. And the more familiar you are with the trig identities, the easier these problems are. Okay, so we have 1 over sine x divided by cosine x plus 1 over cosine x. I can add these up to make one fraction because they have a common denominator, which is cosine x. So that will be 1 divided by sine x plus 1 over cosine x. And then last step is to do your math. We're dividing 1 by a fraction, so we're going to multiply by the reciprocal on top and bottom. Okay, on the bottom they all cancel. And now on top we have cosine x over sine x plus 1 times 1. Well, that's my answer. Cosine x over sine x plus 1. That is the same as that, so we're done. Okay, like I said, these are a little more difficult simply because we got fractions and we got to know how to add fractions. We know we got to add like denominators. We got to flip fractions to multiply, things like that. Number 4, moving right along. 4 says cosecant theta minus cotangent theta equals 1 over cosecant theta plus cotangent theta. So here I would say the right side is more complicated, so I'm going to try to work with that. And also, just so you know, you can work with both sides. You just can't bring something from one side over to the other, okay? You have to work them independently. So this one, I'm actually going to just use some common sense here. Do you see how we have cosecant theta minus cotangent theta on the left? And it's on top, okay? If it were a fraction, if we put that over a fraction, it's on top. So basically, I know in order to make this problem work, I'm going to need that on top. So what I'm going to do is I'm just going to put that on top. Cosecant theta minus cotangent theta. Now, I can't just put it on top. I also have to put it on the bottom because I don't want my problem to be messed up. Okay, that's a quick little rule. You got to if you multiply by something on top, you got to multiply it by on the bottom. Okay, this would be suggestion because basically what this equals is 1. If you were to do cosecant theta minus cotangent theta divided by cosecant theta minus cotangent theta, that's 1. Okay, so basically we're just multiplying this entire thing by 1. So we're not changing the value of it. We're just changing how it looks. Okay. And that was that suggestion right here. Is the fourth one right here. Multiply expressions by an expression equal to 1. That's what I just did. I multiplied it by an expression equal to 1. So on top, we'll have cosecant theta minus cotangent theta times 1, which is itself. On the bottom, these two things look just alike, except one is plus and one is minus. That is called a conjugate. And conjugates, you just multiply the first numbers and the last numbers, okay? So cosecant times cosecant is cosecant squared theta minus cotangent times cotangent is cotangent squared theta. All right, and now, as you can see, we kind of have, you remember anything with a square, you kind of want to lean towards the Pythagorean identities right here, okay? We do not have a cosecant squared minus cotangent squared theorem, but we do have one that says 1 plus cotangent squared equals cosecant squared. And if we just do a little maneuvering here, if we subtract that cotangent squared over, just like that, what does cosecant squared minus cotangent squared equal? It equals 1. So back over here at our problem, basically down here, this cosecant squared minus cotangent squared is just 1. And then what's on top? Cosecant theta minus cotangent theta. And so my final answer is cosecant theta minus cotangent theta, which is what I wanted to get, okay? Again, you know you're finished when you have exactly the same thing on both sides. All right, moving on, we got 2 more. I know these are a little lengthy. Sorry for the length of the video, but that's really the only way to do these, okay? Number 5, we have sine theta and times tangent of theta equals secant theta minus cosine of theta. So I am going to, there's not really a more complicated side here, so I'm actually going to work both sides, but again, I'm going to work them independently. So I'm going to change this to sine theta times tangent theta, we can change to sine theta over cosine theta. I'm going to change everything into sine or cosine for this problem. Secant is 1 over cosine theta minus cosine theta. Okay? And now basically I'm just going to do math on both sides. Over here on the left, we have sine squared theta divided by cosine theta. Sine times sine is sine squared equals, over here on the right, we have to, well, we got to get a common denominator. So the common denominator is cosine theta. We put 1 on the bottom, which also means we have to put 1 on the top. And we will end up with 1 minus cosine squared theta over cosine theta. And then for our last trip, again, we got this square again, so I'm thinking a Pythagorean identity. And again, if we just do a little maneuver in here, I can move this, oops, wrong one. I can move this sine or cosine squared over, just like that. And that tells me 1 minus cosine squared theta is sine squared theta. So I can replace, oops, where are we at? There we go. I can replace 1 minus cosine squared theta with sine squared theta over cosine theta. And we're done. We got the same exact thing on both sides. All right. Last one. Last one's a doozy. Okay. Another one here. I am going to work both sides eventually because there's really not a more complicated side. I'm going to start over here with the left or with the right side simply because everything else seems to be sine and cosine except for this cotangent right here. Okay, so my first step is going to change. I'm going to change that cotangent to sine and cosine. Okay, so that's 1 minus 2 sine squared times a, or sine squared of a, excuse me, we're not multiplying there. And I'm going to change that cotangent of a to cosine a over sine of a. Well, that will equal 1 minus 2. The sines cancel, or the one on the bottom does, and the one on top just, it was squared, so it's just going to be 1 sine now. So sine a, cosine a. And that's about as far as I can take that one, okay? So if I get stopped, if I get trumped up, or I don't know where else to go, that's fine. Just come over here to the other side and work it a little bit, okay? So I'm going to move this over so I have a little room, okay? Because this is going to be rather lengthy. I'm going to multiply this out, okay? So I'm going to write it twice so you can see exactly what I'm doing, because it says it's squared. So squared just means it's multiplying by itself, just like that. And we're going to do the old FOIL method. So we're going to multiply. Sine times sine is sine squared alpha. I don't get to just do the first and the last on this one because they're not conjugates. They're the same thing. You can only do that first and last when they're conjugates, okay? So, oops. Sine times sine is sine squared a. Sine a times negative cosine a will be negative sine a cosine a. And then I come to this one. Negative cosine a times sine a is also negative sine a cosine a. And then negative cosine a times negative cosine a is positive cosine squared a. All right. So we are almost done. Sine squared a plus cosine squared a, again, Pythagorean identity, it's right here. Sine squared plus cosine squared equals 1. So all of that I've highlighted blue is equal to 1. And then we have, well, negative sine a cosine a minus sine a cosine a is minus 2 sine a cosine a. We just add like terms. And there we have it. We have them the same thing. So we are done. All right. Hope this video helps. As always, stay above the line.